Welcome to the final exam, question number 44. And it says that stirrups in a reinforced concrete beam are used, and then blank. And the answers are A, B, C, and D. And stirrups in a reinforced concrete beam. So you can have a beam that's cross-section looks like this. Say it's singly reinforced, it means there's only reinforcement on the bottom side, meaning that you're going to be in positive moment only, so it's probably a simple beam. And then in this beam, let's look at this is a cross section, and here is, let's say it's a pretty short beam, 10 foot or whatnot. So here's your longitudinal reinforcing. Some people call it main reinforcing. Longitudinal because it's going the length of the beam. And then you'll have these stirrups. And these stirrups look like this. And it hooks around right here. And it hooks around right here. And then you'll have typically two up there. And in real life, so actually before we do that, the stirrups, that's how the stirrups look. So you need a little bit more in the end, and then it can get further out, and then probably with that length you won't make it any different. Then you have something called end. So you might have 4 at the end right there. And once again, I'm not doing this, not specific. This is just a generality, saying that there's more in the ends than in the middle. All right, and that's because, remember, the shear diagram for uniform, remember I'm saying uniform, I'll just do this. So this is FBD, free body diagram. Let's say this is assuming we have a uniform distributed load. And then the shear diagram is going to go up like this, and then there, and then your moment diagram is going to look like that. All right, so in your shear diagram is what these stirrups are for. You can see that the shear is higher in the ends, so that's why typically we'll have more. All right, and I kind of explained what shear, or what these stirrups are for, is for shear. And when you're doing, let's say, a pre-stressed beam, well, let's make it look like this. Whoa, that's way off. Horrible drawing. Let's try again. And sorry I'm going out of the way. Maybe I shouldn't try to explain this. And you know what? I won't. I'm not going to draw. I'll use this explanation. So in reality, let's say you have a doubly reinforced beam. You're going to have your negative reinforcing up there, your positive reinforcing down here, and then depending on how high you are, there's something called skin reinforcing, and that's depending on what code you're looking at. So for instance, typically this is like 12-inch. Whoa, that's a 13. 12-inch max. And once again, this is based on code, and they have different things, and I'm sure the IBC might have one thing, or I know that AASHTO has certain requirements for this. But that is the shear. This is for your shear. And remember that if you have, let's say, a big load coming in right here, it's going to want to kind of crack. And what that'll end up doing is it'll start cracking like that for shear. So that doesn't allow that to do it, and this helps with resist the load and shear. So I've tried to explain that enough, and it is late, so I'm going to keep on going. Let's move on. As web reinforcement, where the concrete is overstressed and shear, and it says web reinforcement where it's overstressed and shear, and that sounds pretty good. Yes, it is overstressed and shear, and it's doing that, so that sounds like a good idea. I like that answer. Maybe not as perfect as you could be, but that's all right. to provide the minimum required flexural steel required by code. And that the hint there is flexural. It's not flexural. It's shear. Shear. I'll put an exclamation point. It's exciting. All right. So that's a no. As compressive reinforcement, compression is when you are looking at it like this. And that is not going to do anything for compression because it's perpendicular to it. So that's a definite no. And then D is to reinforce the stem for T-beam action. And that is also incorrect. T-beam action being, that's your compression. I'll say you'll hopefully your compression block will be in your T section. And then you have your reinforcing right there. And it works just like any other reinforcing as long as this, well, I've explained this in the past, but it's more simple if your A lies in your T part of it. It's a lot easier that way. So hopefully it does right there, lie in the T part of it as opposed to in the web. But that is not what the reinforcing is for. So once again, your answer to this is A, and just remember for shear reinforcing, that's what the stirrups are for.